Thank you very much. Thank you. So first of all, I just want to say a huge thank you for being invited to be at this session. The Indian community, the Indian AWS community, is very dear and near to me. You guys have supported me so much, and so thank you for having me here. So to get going, hello, yes, my name is Mike, and I'm going to be putting this presentation. This presentation is going to be showing how I've put together a little bit of a fun, interesting architecture. So we've had a lot of really in-depth and really awesome presentations so far today. This is going to be a little bit of light relief, but I'm going to show you how I use some of the services inside of AWS to make something a little bit fun using artificial intelligence and machine learning, video, and also it's all going to be wrapped up in a serverless architecture. So thank you for my awesome introduction, but I am going to tell you a little bit more about me. So yes, I'm an AWS machine learning hero, and that happened just a couple of months ago, and in no small part due to the support that I've had from India. So again, thank you so much. What I do in my day job, if you like, is I help people to help them learn about machine learning on top of AWS. And if you'll give me a little bit of time at the end of this presentation, I'll tell you a little bit about the course that I'm putting together. It's targeted at the AWS Certified Machine Learning Specialty Certification, and I'll tell you a lot more about that in a moment. Now, something else that I want to tell you about me, and not a lot of people know this, I used to work in television. So I used to be a technical director for a live news production organization over in Europe when I lived over there. And it's through working in television, that I kind of found that I had a dislike for video editing. Now, don't get me wrong. I like editing together my own videos. I like editing together my sort of holiday videos, but editing other people's videos can be really tedious. And so that was kind of the inspiration behind the project that I want to show you now. So let's dive into it. Let's look at what we're going to look at during this session. Video creation. Now, most people will think, and I would forgive anybody for thinking, this is how the video creation process works. We record some footage, whether that be on our mobile phone or with a whole TV crew. We then edit it together and then we shove it up on the internet somewhere and people watch it. And broadly speaking, I guess that's right. But really, if you think about it, and if you tease it apart a bit more, it's actually quite a bit more complicated than that. And so I'm going to propose to you now that actually it looks a bit more like this. So we record some footage, again, on a mobile phone or a laptop or with a film crew with you. We then have to create a shot list, or we have to start cataloging the video that we've got. We have to know which bits of it are going to make it into our final production. Then there is that decision-making process. Someone's got to decide what it is that's going to make it into our final video. Someone's got to decide what bits of film tell the story that we want to tell. Then we can move to an editing process, which is really kind of just a run-of-the-mill kind of just cut and paste exercise at that point, before we then move on to a rendering process, which is, I guess, a kind of technical output of the edit. Then we might have to transcode our video. So depending on where the video is going to go, we might have different kinds of bit rates, different kinds of codecs that we need to use. And so there's that transcode job. Then the video is available on the internet or wherever for people to be able to watch. So I'm proposing to you that really, whether it's implicit in what we do just because we're kind of good at it, or whether it's a very specific function-based, this is really the kind of process that we go through in order to be able to create videos. So that got me thinking, with all this power of the cloud at our fingertips, what can we do? And this is what I'm proposing we look at doing in this session today. This is the aim for today. We're going to have some footage. So we're not going to record footage. We're going to have some we've already had provided for us. So we've got our recorded footage. We're going to do some AWS cloudy automation things. So we're all quite familiar, I guess, with cloud being the platform for automation. There's a lot we can do in there, and that's what we're going to look at in this session. And then we get a video out the other side. I don't want to have to deal with the editing. I want the cloud and the solution that we build to do all of it for us. Now, the solution that I'm proposing and what I'm going to show you today, it's a little bit fun, but the tools that we're using, the services that we're using, could definitely be used in more serious business level applications as well. So there's a little bit for everybody. Now, I wouldn't be much of a solution architect or a systems analyst if I didn't have a bullet point of lists of requirements. And so I'm not going to have tons of bullet points in this presentation, but there are going to be some on this slide. So what do we want to be able to achieve? Well, we want to be able to listen, or I guess watch the video. We have to have something in the process that does that, because we don't want to have to do it. Then we have to have something that understands that video. So understands what's inside of it so that we can start to make a decision. We need to decide what it is that we're going to edit. So you'll see now that these bullet points, I guess, align to that diagram that we looked at just a moment ago. And then once we've made that decision, we need to have a process that does the actual editing. So we need to actually edit the actual file, spit it out, transcode it, do everything else, and orchestrate the whole thing together. So we need to look for something that's going to do that for us as well. Now, those are all, I guess, what I might classify as functional requirements if I'm putting that kind of enterprise language hat on. Let's look at the non-functional requirements. I want it to be robust because I want it to just work when I submit a video to the system. I want to make sure that I don't have to look at it again. I want low management, and I want it to be highly scalable. I'm not really sure why I want it to be highly scalable, because it is just me, but maybe we could roll this out to everybody in the world to create their viral video sensations. So it needs to be highly scalable. And I guess it's just part of the challenge. So with those two lists, if you like, of requirements, let's have a look at what kind of, broadly speaking, what technologies we can use to throw at these. And what I'm going to suggest to you is that we're going to use artificial intelligence, not exclusively, but predominantly artificial intelligence to do the exciting bits of the listening and the understanding of the video. And then we're going to use serverless technologies on the other side, because honestly, everybody wants serverless in their applications. Everybody wants serverless in their presentations. So I'm catering for machine learning, artificial intelligence, and serverless. So surely I get all the ticks with this. And the final thing that I want to do is I want to build it entirely on AWS. Now, that's not a real world, real requirement, right? You use the best service that matches your requirements. But I tend to find that most of the best services live on AWS anyway. And for this particular project, I wanted the challenge. So I wanted to do it entirely with AWS services, which was a little bit of a challenge. But I found, spoiler alert, you can absolutely do it. And I'll show you how. So let's jump into the process. Let's talk about how I did this, but at a higher level to start with, before we dip into the actual console itself and have a look at some of the running code. So the first thing we need to do is we need to listen to the video. That's what we've established. And so we actually need a video to actually listen to. And so the video I've chosen for this is Andy Jasay's 2019 reInvent keynote speech. I didn't necessarily ask to do this, but I'm sure he's fine with it. It's 2 hours and 40 minutes long. So it's really quite a long video, and it's useful from that point of view to demonstrate what we're going to do here, because the last thing I want to do, well, no, hang on. I absolutely did listen to this live when it was on, but I don't want to have to listen to it again in order to be able to figure out which bits I want to edit from it. That's my excuse anyway. So how can we listen or watch this video automatically so that later on we can decide what to edit out of this video? And the service we're going to use for that is Amazon Transcribe. Now, Amazon Transcribe is an artificial intelligence service that sits inside of AWS. And right now, what I'm probably going to do is I'm just going to pause for just 1 second. And I'm going to hop over to a slide, which is actually from an AWS slide deck, so I didn't make it, which explains a little bit about the machine learning and artificial intelligence services that are available from AWS. And we'll see where Transcribe lives, as well as some of the other services that we're going to use today. So here is the slide. Again, I didn't put this together, but it's nicely and succinctly explains, I think succinctly, you might have to zoom in a little bit, but it explains the different frameworks and services that AWS have in relation to machine learning. So down the bottom there, not actually where I'm highlighting with the pink box, never mind. Right down the bottom there, you'll see the ML frameworks and infrastructure. So these are essentially the ultimate building blocks for machine learning. And broadly speaking, they're actually the building blocks for machine learning generally. So we've got frameworks like TensorFlow and MXNet. We've got abstractions of those like Gluon and Keras. But we've also got the actual server infrastructure as well. Server infrastructure that AWS has specifically put together to cater for machine learning workloads. So we've got servers with GPU acceleration, with special elastic inference endpoints, all of this kind of stuff. So really sophisticated low-level infrastructure down at that level. Now, using that is a little bit complicated, and it's certainly beyond the scope of what we're going to talk about here today, and it's certainly beyond the scope of the project that I've put together. So let's walk up the stack and look to see what AWS have done to make machine learning a little bit easier inside of the AWS environment. And if we go up one level, we have that level in the middle there, which is called ML services or machine learning services. And predominantly in that layer is Amazon SageMaker. Now, Amazon SageMaker isn't actually a service, I don't think, in that way. It's more of a collection of services and collection of API endpoints. It's documented examples. It's environments you can develop in. It's container images. It's a whole bunch of stuff. And the SageMaker Studio IDE as well, all thrown into here. So it's a very capable environment, if you like, and collection of things that somebody who would say that they're a machine learning operationist, an ML ops operator, could live in there quite comfortably, deploying infrastructure and building machine learning solutions. And it abstracts away from those frameworks and from that infrastructure to sort of do the undifferentiated heavy lifting, which of course is AWS's famous marketing term. But that itself as well, that layer requires still some specific level of knowledge to be able to get the best out of it. You can build your own models. You can do a lot of very sophisticated things in there relatively easily compared with doing it from scratch. But on top of this, AWS have built their AI services. And you can bet that the AI services that they've built make use out of everything else that's in the stack there. But they've built them for us to be able to get easy access to really powerful machine learning solutions. So right up at the top there, we've got API-driven services. So if we want to just write an app, we can bolt in these different services to do really powerful machine learning activities. And one of those is Amazon Transcribe, which is just here. And that's what we're going to use. And we're going to talk about how that works. And we'll use some other services from this layer as well throughout the solution. But a really important point that I want to get across here is that just because these are abstracted services and they're available at an API level, that doesn't mean that they're not powerful. They're actually very powerful and can be used for production workloads. So they are absolutely to be considered. If an AI service does what you need, you should think about using it rather than going building your own, because that's, I guess, the entire philosophy around cloud computing. Okay, so let's move away from AWS's view of their own machine learning services, and I thank them for kind of letting me borrow that slide. And let's go back to my presentation and where we're going to use these AI services to automatically edit my video. So we use Amazon Transcribe. We take the video that we have, all 2 hours and 40 minutes of Andy talking, and we present it to this service. We then have to wait a little while, but whilst it churns through that, it transcribes that video into text. And so hopefully you can see here, and I can show you this in more detail when we jump into the console. But here is a snippet from the first part of the response, where it's telling us the text that's inside that speech. And as you can see there, it's thank you, hello, and welcome to the 8th annual AWS reInvent. It's quite a natural thing for him to be saying at the beginning of the presentation. Now, That is then followed by all of the rest of the text. All 2 hours and 40 minutes of the text is all together in this one big chunk of text. And interesting while that is, it's not really that useful for us when we want to edit that video at a later stage and figure out what words we want to edit. So there is another part of the response from Amazon Transcribe which will help us out. And that's this part, which is underneath. Is the second part, where it takes each individual word transcribed from that video and tells us the start time of that word and the end time of that word. So in seconds, or seconds and hundredths of a second, it tells us the start and the end time of that word. So this is starting to become much more useful when we are wanting to sort of place a marker in the video and do some editing. So Amazon Transcribe, it caters for the listen aspect or the watch aspect of our video. Let's move on then to understand. And to understand, we're going to use another one of the artificial intelligence services, the AI services from AWS. And this one's called Amazon Comprehend. It's in the name, right? It's going to comprehend something about the text which we've just got back. Now, Comprehend is a fairly large kind of Swiss Army knife of natural language processing. It can do quite a lot of things, but we're going to look at one thing in particular, and I'm going to talk about a couple right now. So we can take the individual words that we have, and in the final solution, we're not necessarily going to take all of them, but we'll take some of the words. We can pass it into Comprehend, and it can tell us what the language structure of that word is. And so in this particular case, you can see a little snippet that's returned back from the service, which tells us that the word more is an adjective. So we've asked it to tell us about more, and it's told us that that's an adjective. Now, that's a really, really simple use case for Comprehend. It can do so much more than that. And if I wanted to, or if you wanted to extend this project out further, this is a fertile place to do just that, to look at how we could comprehend or understand the video even more. And one of those things is we could look for sentiment analysis. So Comprehend can do this. So we can pass in sentence structures even into the service, and it will give us the sentiment of that sentence structure. So here you can see an example of a return for such a call. And we've said, give us the sentiment of this, and it said, it's positive. And you can see there the sentiment score. It's got the positive, negative, neutral, and mixed. That's not necessarily how positive it is or how negative it is necessarily. It could be more aligned to how sure Amazon Comprehend is that it's positive. But nevertheless, there's sort of 6 of one and half of a dozen of the other. You can use that to gain the sentiment of the text that you have. Now, we don't do that in this solution. We're going to stick to the adjective thing from before. So we have there with that service, with Amazon Comprehend, a way to understand the video that we're going to try to edit. And everything so far has been serverless. We haven't had to touch a single server. So the next thing that we need to do is we need to decide, if you remember from the bullet point list that we looked at before, we need to decide. Now that we've got all this information from the video, we need to decide how we're going to edit it together. What are we going to take from the video and put it into our edit? And so to do that, as you can see, I'm going to use a Lambda function. Lambda function, of course, is the serverless code that we can run. And with that small piece of code, I can codify the rules that I want to have, the logic that I want to have, that will decide how to edit this video together. Now, it can't do the actual video editing, but it can decide what the edit will look like. So if you remember from our trace through of all the different steps, it's that last person before edit. So with this Lambda function, we're going to take the transcription that we've got, we're going to pass it into the Lambda function and ask it to do some analysis on it. And in this case, it's just going to look for all of the words in there. It's going to look for the most commonly used words and find the first word, which is an adjective. So something which describes what is going on in the presentation. So we could well expect this to be like great or better because Andy's very passionate about what he talks about on stage, and everything at reInvent in the keynote is bigger, better, shinier. You get the idea. So we pass the transcription in. The Lambda function will use the language capabilities of comprehend to find the first adjective. And then we can just do a bunch of processing on that and spit out an EDL. Now, an EDL is a video term. It's from back in my TV days, but it's an edit decision list. Essentially, all we're going to do is output a text file. And inside of that text file, we'll have an in point and an out point for all of the different clips that we want to clip together. And so in this case, it's going to be the boundaries of each of those words that we want to edit into our final video. And that gets stored out in an S3 bucket as our edit decision list. Okay, so now we've finished sort of deciding what we want, and we've even noted down all of the clips that we want. The question now comes, how can we edit this video? And when I was putting this together, this is what made me scratch my head, because I wasn't quite sure. I did start to play around with EC2 instances or Docker containers that had open source libraries inside of them that could do this kind of stuff, and it kind of worked. But managing those kinds of things is a bit of a headache. That's why serverless is a thing. I don't want to have to manage servers. I want it to be robust. I don't want to have any management overhead of patching them and all that kind of stuff. So I was very happy when I came across AWS Elemental Media Convert. Now, the reason why I'd passed it by in the past was because it says media convert, and that's great. We've had Elastic Transcoder for a while, and that can also convert media types. I'm sure this is more capable. But one of the things that this can do, if you dig in the documentation, is it can take, essentially, an edit decision list, and it can only transcribe or convert particular parts of the video and edit them together and spit them out. This is fantastic. This is exactly what I wanted. So we're going to use AWS Elemental Media Convert as a serverless video editor to take that decision that we've got, which is set up inside of our S3 bucket. We'll pass that into a Lambda function, which can call media convert in the appropriate way, because we can't just throw a text file at media convert, kind of. We have to call it through our Lambda function. So we'll do that, and then AWS Elemental Media Convert will spit out an output into our output bucket. And at that point, we will have edited a video automatically. Whether you think it's of any use or not, it's up to you. It's kind of funny, but absolutely the components that we're looking at here could be used for serious applications as well, if serious is your thing. So let's take a look. Let's take a stand back at all the different services that we have identified and that we're going to use. We've got a bunch of S3 buckets. We've got Lambda functions, which are going to be used for certain things, the AI services, and the media convert service as well. So the question now comes, how can we organize this process? How can we have it all orchestrate together? And so we now step into serverless architectures. And the easiest, I guess, or the simplest or the most straightforward serverless architecture is event chaining. So we could have a look at doing this. So we could have an S3 bucket. So we get an S3 bucket. If we put an object inside of the S3 bucket, so for example, the video that we want to edit, we put that in there, it will create an event for us. And that event can be used to trigger something, such as a Lambda function, which can then be used to trigger something else. So we could get the Lambda function to send that job into Transcribe. And this works well. We like this. The question comes, though, as to what we do next. We could output the output of Transcribe into a bucket. And then we could have another event on that, which calls another Lambda function and chain things together that way. But the problem with doing it like this is that there is more to be done after this stage. So there's actually a whole bunch more stuff that we have to do. We need to, or we want to, maintain some kind of state throughout all these different steps. So we don't want to have to pass information between services that don't actually care about file names, for example, so that ultimately Media Convert will know what word we chose so it can name the file appropriately, all that type of stuff. That's state that we want to have sort of be in the background. So as we step through this process, we want to maintain state. And if you've used AWS serverless architectures, you're probably screaming this at me right now. or maybe it's in the chat, which by the way, I can't see, but thank you for your comments. We're going to use AWS step functions. So AWS step functions can host state machines, and these state machines are responsible for orchestrating various services, predominantly in this case, probably Lambda functions, but they can also call out to services in their own right as well. And so we're going to create a little graph like this, which is going to link together the different parts of the process. So the transcription, waiting for the transcription to finish, deciding on what that clip word is going to be, putting the edit decision list together, and then passing the job to Elemental Media Convert at the end. And so this is what step functions does, and it does it very well. And it's another serverless service. So this architecture, 100% serverless, automatically edits our videos. But don't just take my word for it. Let's jump into the AWS console. If the demo gods will be happy and pleased with me and let me do this, let's see if we can get this working. So here we are inside of the AWS console, and we'll have a look at the different pieces, the bits and pieces that I've got that actually makes this work. So first of all, I'm going to go and have a look at my S3 buckets, and I'm going to actually kick the job off because it can take some time to do this. I'm not sure if we'll see one actually go through the process, but I've got some samples that I can show you, so don't worry. And so in this S3, in this account, I've got 3 buckets. I've got my input bucket, my output bucket, and I've got a clips list bucket as well. So this is where my edit decision list will go in. So the input bucket, as you can probably guess, is where we put the video, and we put the video in there. It's going to trigger off a Lambda function, which triggers off our step functions. So we're going to go and do that right now so that we can start the process. And a little trick here, if you do this kind of thing, yes, it does want me to essentially upload a video into this bucket, but that could take a little while. So what I'm going to do is I'm just going to rename this object, and renaming this object has the same effect. It will trigger off the function that will trigger the event in the same way with the way I have it set up. So I'm going to go into here and say actions. I'm zoomed well in here, so hopefully you can see what's happening, but it also means that everything's rather in unusual places for me. There we go. So we're going to rename it. Let's rename this 3 because I was testing with it earlier today. So I press the save button, and that will basically simulate that a video has just been uploaded into the environment. Okay, so now I've done that. An event has been created. It's triggered off a Lambda function. That Lambda function has gone and triggered off our step functions. And I can show you that by going over to step functions inside the console. So we're going to have a look over, over here. And you can see that I have one step function state machine defined, and I'm going to have to refresh this. And hopefully we'll see that it's going. Hang on, let's go back out. Let's go back to state machines. Yes, we do have one running. Here we go. We have one running here. Thank goodness. Let's dip into this and see if we can see it in process. So we see the executions. Yes, there we go. It's refreshed now. So we have this running occurrence of our state machine right here. So what this means is we are currently in the process of going through our steps of our machine. So let's just navigate into there.
Sorry to interrupt. Could you please
Yes.
refresh the screen?
Can I refresh the screen, did you say?
Yeah, yes.
Yes, I can. Are you unable to see it?
No.
Right.
It is like broken.
Yes, I see that as well. It's right in front of me. I wonder if I stop screen sharing and then start it again, whether that would help. Let's try it.
Okay.
This could all go terribly wrong, or it could be perfect. Screen share. So I am doing this from Australia with our internet, which is as good as it is. So I'm pressing screen share, and I'm now not getting an option to share my screen. Maybe that was the wrong thing to do. Oh, here we go. No, it's come up. So let's say there. Bear with me 1 second, folks. Allow. All right. How's that? You can see that now, yes. I don't know what the last thing was you could see, so hopefully it all made sense. So we've renamed the object inside of the S3 bucket, and it's now kicked off this this state function, state machine, step functions, lots of names. And so if we look inside of here, we can actually use the graph inspector to show us what's currently going on. And hopefully you can see that. It's a little small. And notice that it's sort of a little bit not quite right in the live stream too, but you can see the actual step machine graph inspector, so at least that's good. So you can see there that it looks quite similar to when I had it on the slides before, but it's got a green box at the top there that's saying that the transcription job has been kicked off. And it is currently in the wait for transcribe section. So what's happened here, kicking off a transcribe job is an asynchronous call. So we say, please transcribe this video, and then it goes off and does that. But we have to sort of progressively ask, are you finished yet? And so that's what this loop does that's here. So we actually have a Lambda function whose sole job in life is to go to transcribe and say, have you finished transcribing yet? And this is successfully running, but it's saying, no, I haven't finished. And so it's going round and round here in this loop currently. So we can see this in the definition of the step function, if everything catches up with me. And it kind of does. Maybe I should, if I scroll more, there we go. It's a bit strange there, but you can kind of see the code. And so this is how we define the state machine, the step function. And so we say which Lambda function we want to call, and then we can have decision points inside of the state machine to say, okay, we put a value into the state. Look at that value. If it's the value we're looking for, then carry on to the next step. Otherwise, go this other way. And that's where this conditional routing comes in. And so we've got something in here which is going to look for the transcription status as completed, which is right there. Hopefully you can see that. If it's completed, it'll carry on. If it's not completed yet, it will loop around again. Or if it comes back as failed, then we'll go to an error state. But so far that hasn't happened. That's just a catch-all just in case. So let's go and have a look at the video that I uploaded into this process. So if I just slide to my other screen, hopefully this will work. Hopefully you'll be able to hear it, because that's kind of the point. But this is Andy Jass's keynote speech. Yes, it's 2 hours and 40 minutes long. No, we're not going to watch it all. So hopefully you can hear this too and see it somewhat. So
thank you. Hello.
Lots of copyright related reasons, I'm not going to play the whole thing.
It is awesome.
But hopefully you can hear that. Anyway, okay. So that's the video that we're going to ask it to transcode. Let's go and have a look at what the outputs look like at the various stages that we've got inside this code. So here, I've got the output of the transcription job. Now, this isn't the one we've currently initiated because that's still going, but this is one that I've done on this previously, sort of a ready-baked, if you like. And hopefully you'll be able to see this more or less. So you can see here at the top here, we have the transcript of the entire video. And if I kind of carefully scroll across, you'll see that it's really, 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 really long. Of course, this line represents over 2.5 hours worth of speech. So it's all in there. But if we just scroll down here, you can see what I was talking about before, which is the JSON structure, which shows us each individual word and its start time and its end time in there. And so that's the word thank and the word you, and then a full stop, and then hello, and on it goes. You can imagine this file is quite long. So that's what we've got that comes out of transcribe. Let's go and have a quick look at the Lambda functions that we've got. The streaming will allow me to show you. So let's go over to Lambda functions. Let's give you a sense of what I've got in here. And I can't go through all of this code because I'm no developer and you do not want to see much of my code. That's for one thing. But also, there's too much of it. So let's go and have a look in here at clip word, for example. So clip word is the function which is going to take the transcription and then try and extract from it the word that we are going to edit together, chop, chop style, into our final video. And hopefully you'll be able to see some of this. Maybe I refresh the page. It is what you suggested, wasn't it? See if that sort of like gets the whole thing to refresh. I can see it in front of me. Maybe I should turn my camera to the screen here. You can kind of see it. Let's see what we can see. The idea with this then, this Lambda function, what it does is it takes the transcription job that's been done. Now that transcription job has been placed into the state of that step machine, of that step function. So the Lambda function just has to go and grab that, pull it in and start to process that data. So it does that by doing a word count first off. Let's just see where that's done. You can just about see that. So it gets the word count. So it goes through every single word that's in that transcription, and it finds the most popular word. Actually, it ranks them all by unique words, ranked by how often they're used. And then down here, this is where we go off and call comprehend. So we're calling comprehend directly from this Lambda function. We don't call it for every single word that's in that list, because that would take forever and actually might end up being quite expensive as well. So we just send the first most popular word and then keep going down that list until we find the first adjective that it spits out. So that's what that's going to do. And that's the Lambda handler, which sort of ties the whole thing together. So then, if I just go back to my my Lambda functions, scroll to the top here, go back and have a look at them. We then use a different Lambda function to go and create the edit list itself. And this is a great example of chaining together our Lambda functions using the step machine sort of working for us. So rather than passing the message from the previous Lambda function that we looked at onto the next Lambda function, we just pass the output, in other words, the word that we're going to look for. We pass that back into the state machine, and the state machine has that available then for the next function in the loop. And it means that our Lambda functions are more loosely coupled. So let's go and have a look inside of here. And this Lambda function is going to pick up that word from the state of the step function state machine, and it's going to go and create that edit decision list that I was talking about before. And the only thing that this function has to do, which is a little bit quirky, is that it takes the time of each word, so the seconds and hundredths of a second, and converts it into seconds and frames, because now we're moving into a video editing world. And that's how we talk. We don't talk in hundredths of a second, we talk in frames. So let's have a look, rather than looking at this code. Hopefully this works for us, and it does. Let's go and have a look at the output of this function. And this is what it looks like. So very, very simple, very, very straightforward. You can more or less see all of this. You can't quite see the exact left-hand side of it, but that doesn't really matter. You can see the start time code, and the end time code, and that's all you need for every single occurrence of what we want to edit from this video. So that's what we've got inside of there. Now let's go back and have a look at our step function. I'm imagining that it's probably still going. Let's have a look at it. Yes, it's still doing the transcription, actually. So that whole process, the whole process of running this particular one on this particular video is about 15 minutes. And so rather than me just sit back and fold my arms and wait for it, I'm going to show you an example of what it spits out. So hopefully this works, and you could hear the video from before, because, well, this is it, folks. This is, I don't know, the viral video sensation that I've managed to make. Drum roll, please. It'll somewhat work. Hopefully you'll be able to hear it. So this is the 22-second version of that keynote speech.
So
hopefully, as you can hear there, I can't actually hear it, but through the magic of this streaming, hopefully you can hear that it's clipped together every single instance of the most commonly used adjective in the presentation. So there you go. Viral video sensation, I don't know. How could we extend this? We could make it so that it could automatically upload that to YouTube and have an entire channel of these things done. And I don't know. It's a fun project. I think it's a fun project. Okay, so that's still going to be going on for some time. We could come back and look at it when we get to question time if you want. But let's dash back to the presentation before I run out of time and have a bit of a wrap up to see how we've gone with this solution. So what have we managed to achieve? Have we managed to achieve what we set out to achieve? Well, first of all, we wanted to be able to listen to the video. And we were able to do that with Amazon Transcribe. So an artificial intelligence service that all we had to do was throw the video at it, and it was able to transcribe that video for us without us having to do anything more. It catered for our needs. Then we have understand, and we've used comprehend to understand our video somewhat. But as I said before, the one place which is fertile ground for making this even more sophisticated would be to use comprehend a little bit more with a bit more sophistication to figure out maybe the parts of the presentation which have the highest sentiment for the highest positive sentiment, for example. But I can imagine there'd be quite a lot of that going on in that presentation. We've decided what to do. We've figured out how to edit it, and we used a Lambda function for that. So we codified the logic that we had inside of that Lambda function. We then processed the video. Now, and that was partially done by Elemental Media Convert using the edit decision list that we created, and also using step functions, state machines, to tie the whole thing together. Was it robust? Well, pretty much, apart from the little streaming glitch. Trust me, on my side, it looked perfect. So yes, it's robust. It's running in the cloud. Low management because we're using serverless throughout, and highly scalable too. Again, pretty much because we're using serverless architectures. So Lambda functions scale really well. The artificial intelligence services scale really well as well. So we are able to have hundreds of thousands of videos at any time being processed through this architecture. So we've managed to do it. Let's just have a little bit of a grounding just for a second. In the real world, where could we use this? Well, clearly I could use it on my own YouTube channel to become a viral sensation, but parking that, what could we use it for? Well, I'm going to suggest to you we could use it for recording meetings, or we could use recordings of meetings and then look for certain things that happened in those meetings, especially if we've got archived footage of meetings. Maybe it's only audio. We could do the same thing. And we could pull out just individual parts that we want to highlight to other team members, for example. We could use it for media monitoring. So a lot of companies want to know what's being said about their company in the wild. So we could use media monitoring. We could have snippets of news coverage coming in, and we could look to see whenever they might mention us or our products. Maybe we could create a whole service around editing video, like a word processor. So we could adjust the words, and it would go and basically re-edit together our video for us. It'll take a bit more doing to get there. I think that's a pretty fun example of what you could do. And I want you to let me know if you've got any ideas what we could use this for. So I absolutely want to hear from you. In a moment, I'm going to put up my my LinkedIn profile. Get in touch with me on LinkedIn, and there's $50 AWS credits for the best answer. So that was just something I thought of just then. Absolutely, we're going to do this. $50 AWS credits for anybody who can think of a really awesome, fun or otherwise use case for this architecture that we've put together. So let me wrap up just by recovering what I was talking about before. Let me wrap up by recovering. That's not what I meant to say. Let me wrap up by talking a little bit more about what I do in my day-to-day. As I explained before, I help people get certified in AWS. I've been doing that for a long time. And right now I'm focusing on helping people to certify with the AWS Certified Machine Learning Specialty Certification. So the kind of stuff that we've looked at in this presentation, it is featured in the certification, but we go lower level as well. So we get into SageMaker. We look at how we can use SageMaker to build models. We also, though, look at how machine learning even works from the get get-go. Let's talk about the fundamentals of machine learning so that you can build off of maybe your existing AWS knowledge up until the point that you could pass this certification, or even just using machine learning in your day-to-day, in your work environment, or for your own fun hobbies. So the link to this course is at the top of the screen now. So feel free to come along, have a look. I present lessons in a similar kind of way, I guess, to the way that we've done this session now. There's lots of slides and lots of animations, but we also get hands-on. So we absolutely dive into build environments, and we do real machine learning and real solutions with real machine learning algorithms, for example, getting down and using SageMaker too. So that's the course. And I explained right up at the top of this session how grateful I am to the Indian community in particular for the support that you've shown me over the years. And so I wanted to give something back. I was very, very grateful to be invited to this conference and to this day. And so, yes, drumroll please, I have got a code to give away for my course, and it's a whopping 50% off. So it's a special limited offer just for now. So please, yeah, do use this code. It's AWS UG India, the hashtag we're using for this event, and it'll give you 50% off this course. And it will be amazing to see you in on the course, going through your machine learning journey with me and with the rest of the community which is taking the course. It's in early access right now, which means that the course is still being developed. It's an ideal time to get in right now, whilst there's a lot of discussion going on about how the course can be best put together to show you what you want to see in order to be able to pass this exam. So go to this link, use this code, and please do also connect with me on LinkedIn. And don't forget, the best use case for what we've looked at in this presentation so far, there's a $50 AWS voucher, $50 USD voucher coming your way. So that's it. That's my presentation. Thank you so much for watching.